Hello everyone, welcome to Easy BTech channel. So in this module, we will see how to do the subtraction operation using 1's complement method. So earlier we have seen subtraction using normal binary subtraction. So in this class, we will see how to do the subtraction using 1's complement method. So the advantage of doing the subtraction operation using 1's complement method is so we can use the same adder circuit. We can use the same adder circuit to do the subtraction also. That is the advantage of using 1's complement method. So we don't require any additional hardware. So hardware will be reduced if we use the 1's complement method. Now we will see the procedure how to do the subtraction using 1's complement method. So what we have to do, for example, if you want to subtract B from A, so in that first we have to, the first step is we have to find the 1's complement of B. So whichever number we would like to subtract, so that number 1's complement we have to find. So if we call that as B suffix 1 or B1, then we have to add that B1 to the first number. We have to add whatever 1's complement we have found, so that we have to add to A. So then if we obtain any carry after the addition operation, if we obtain any carry, so the next step is we have to add that carry back to the result. So whatever result we get after this addition operation, if we get carry, that carry we have to add back to the result. So this is known as end around carry. So if you get a carry, we have to add 1 to that result, right? So this indicates the result is a positive number. Result is a positive number. So for example, if you don't get carry after this addition operation, so there are two cases. One is if we obtain carry. The second case is if we don't get the carry. So if you don't get the carry, the result is negative. The result is negative and is in 1's complement form. The result is in 1's complement form. So these are the steps that we have to perform to do the subtraction operation. So what we are doing, instead of subtracting, we are adding. Which we are adding? We are adding the 1's complement of the negative number. So that is why this is called the subtraction using 1's complement. So the subtraction is converted into addition by taking the 1's complement of the negative number. 1's complement of the negative number. So we will look this with the help of an example. So these are the given numbers. We have to do subtract 5 from 3. So here there are two cases. For the two cases we will get the two steps. So one here, if you observe, we are subtracting a larger number. We are subtracting a larger number from smaller number. We are subtracting a larger number from smaller number. So as I have said, first we have to represent these in binary form. So first we will represent plus 5. So we will represent in 4 bit. We will represent these numbers in 4 bit. So plus 5 in binary, we can represent 0, 1, 0, 1. So the next step is we have to represent minus 5 in 1's complement form. We have to represent minus 5 in 1's complement form. So how to represent minus 5 in 1's complement form? Simply interchange 0 to 1, 1 to 0, 0 to 1, 1 to 0. Next, second step is represent this 3 also in binary format. So if you represent 3 in binary format, the result is 0, 0, 1, 1, 0, 0, 1, 1. So now add the two numbers. So 0 plus 1, it is 1. 1 plus 1. If we add 1 plus 1, sum 0, we will get carry 1. So if we add this, we will get 1. So again, if we add 1 plus 0, 1. So the result is 1101. So as we have seen in the procedure, so here there is no carry. There is no carry. So if there is no carry, what it indicates? It indicates the result is negative. It indicates result is negative. It indicates result is negative, and the result is in one's complement form. It is in one's complement form. One's complement form. Right? So to get the decimal value of this result, so again we have to take one's complement of this and add minus to the result. So if you take one's complement of this, it is 0, 0, 1, 0. So what is the corresponding decimal equivalent? So this is minus 2, right? So if you subtract 5 from 3, the result is minus 2. So this is how to do the subtraction using one's complement method. And to get the result, the corresponding decimal equivalent 1101, right? There is another procedure. So what is that means? Assign the weights 2 power 0 and 2 power 1, 2 power 2, 2 power 3. So first assign to the MSP minus weight, So what will be the result? Minus 2 power 3, it means 8. 2 power 2 means it is 4 plus 0, and 2 power 0 means 1. So this is 1. So what we will get? Minus 8 plus 5, it is minus 3. Then we have to add 1 to the result. We will get the corresponding decimal equivalent for the number which is in one's complement representation. So the decimal value of the number which is in one's complement we can get in two ways. This is one method, get the one's complement and assign minus sign. So because here the result is negative, so that's why we have done this way, or you can find this way also, right? So here we are subtracting a larger number from smaller number. So in the next example, we will see we will subtract smaller number from larger number. So this is the second example, and the second case we are subtracting smaller number from larger number. So the first step is we have to represent the negative or whichever number we are subtracting that in one's complement form. So here also we consider 4-bit representation. So if we consider 4-bit plus 2, we will represent 0, 0, 1, 0. Next, represent plus or minus 2 in one's complement form. Minus 2 in one's complement form. What is the corresponding result? 0 to 1, 0 to 1, this 1 to 0, and this 0 to 1. Right? Second step, represent the other number also in 4-bit. So 6 in 4-bit, if you represent 0, 1, 1, 0. So now add both the numbers. So 1 plus 0, it is 1. 1, 0 plus 1, it is 1. Now 1 plus 1. 1 plus 1, it is 0, sum 0, carry 1, right? Now again 1 plus 1, so sum 0, carry 1. So here in the result we got a carry, right? So we have considered 4-bit, we got a carry. So what we have to do? We have to add the carry again to the result. So if we add carry to the result, so 1 plus 1, sum 0, carry 1. Again if we do 1 plus 1, sum 0, carry 1. So 1, 0. So whenever we get a carry using one's complement method, so and add that carry to the result, and the result indicates it is a positive number. It is a positive number. What is the corresponding decimal equivalent for this? Corresponding decimal equivalent for 0100 is 4. Is 4, right? So what we will get if we do the subtraction 6 minus 2, it is 4, right? Both are correct. You can cross verify the result also in this way. So we will get two cases. One is In the earlier case, if you see the earlier example, so here there is no carry. If there is no carry, it indicates result is negative. So to get the corresponding decimal equivalent, take the ones complement and assign -1. So you will get the result. The second case is when there is a carry out of the addition operation, you add that carry back to the result and it indicates the result is a positive number. We'll see one more example. So here we are subtracting 25 from 14. So we would like to use 8-bit representation, 8-bit representation. So in the problem statement, it was said 8-bit representation. So whatever number of bits representation you was asked to do, you have to do represent in that way. So the first step is, first we will represent plus 25 in 8 bit. So we'll write first 8 bit, 240, 241, 242, 243, 244, 245 and 246 and 247, right? So plus 25, how we can represent? 2 power 4 means 16, right? So 2 power 5 means 32, but here we have to represent only plus 25. So these bits we doesn't require 0, 0. So 2 power 4 means 16. So we can take 16. Next 2 power 3 means 8. So 16 plus 8, that also we can take. 16 plus 8, 24. Next 2 power 2 means 4. That we doesn't require, right? So if we take 2 power 2 also, it is already we got 24. 24 plus 4, it will become 28. So we need not to take 2 power 2 also. Again, this 2 power 1 also we need not to take because we already have 16 plus 8, 24. If you take this 2 also, it will become 26. So you need not to take this 2 power 1 position also. 2 power 0 position we have to take. So this is the representation of plus 25 in 8-bit binary, right? So 2 power 4 means 16, 16 plus 8, 24, 24 plus 1, 25. Now we will represent minus 25 in one's complement representation. In one's complement representation. Why? So what we have to do? Simply change zeros to 1, 1, 1. So these two zeros and these zeros to 1 and this is 0. So first step is completed. Now represent 14, 14 in binary. So again you would see 2 power 4 means 16. So this position, up to this position we doesn't require. So 0, 2 power 7 0, 2 power 6 also 0, 2 power 5 also 0, 2 power 4 also 0, 2 power 3 we have to take. 2 power 3 is 8, 2 power 2 is 4. So 8 plus 4, 12. Again 2 if you take, 12 plus 2 it is 14. So this we have to take 0, right? It is 2 power 3, 8, 8 plus 4, 12, 12 plus 2, 14. So this is the representation of 14 in 8-bit representation. Now add, so this is 25, right? In minus 25 in one's complement representation and this is 14 in 8-bit representation. Now add both the numbers, 0 plus 0, it is 0, 1 plus 1. So if we do 1 plus 1, we will get sum 0, carry 1. So here we have 3 ones. So whenever we have 3 ones, we get sum also 1, carry also 1. Again 1 plus 1, again 1 plus 1, sum 0, right? Carry 1. So if we add, this will give 1 and this will give 1 and this will give 1 and this will give 1. So here also in the result we didn't get any carry, right? No carry. So that indicates the result is negative. Result is negative and it is in one's complement form. Result is in one's complement form. Result is in one's complement form, right? To get the result, take again one's complement of this. If we take one's complement of this, one's complement of this, 0, 0, 0, 4 zeros, right? We have 4 ones. So 4 zeros and then 1, 0, 1, 1. What is the corresponding and assign minus sign to this? So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So 8 plus 2 plus 1. So 11 minus 11. So what we'll get? If we subtract 25 from 14, we will get minus 11, right? So the result is also minus 11. So whenever we are doing the subtraction operation using one's complement, so if there is no carry, that means it indicates the result is negative and it is in one's complement form. To get the corresponding decimal equivalent, we have to take again the one's complement and assign minus sign to this, right? So in this module, we have seen how to do the subtraction operation by using one's complement. So with the help of one's complement, we can do the subtraction operation also like addition operation. So that is the advantage of one's complement method to do the subtraction operation. So thank you for watching. I request everyone to subscribe to EasyBTech channel and share to your friends. So in the next module, we will see subtraction using 2's complement method. Right? Thank you.